So the reason it's only 10 is why? Because they intersect. And so some of them like don't need to have to be there. Like if it was just 4 lines that were by themselves, and you put 4 on each, that'd be 20, right? But some of them intersect. So there would be 2 marbles here, but one of them wasn't needed because like you only need to put 1 there. And so each of those you can take off a marble. So that's why it's only 10. Okay, we're looking at direct and inverse variation, lesson 60 today. Direct and inverse variation. All right, so if A varies directly as B, or if A is directly proportional, those mean the same thing. This is the equation that you would make. A equals K times B. Yes. I left off the S on as, and so it was just A. So if A varies directly as B, or if A is directly proportional as B, your equation would be A equals KB. K is just a constant. So if it's directly K times the second one, they get multiplied by each other. If it's inverse, varies inversely, or it's inversely proportional, A equals K divided by B. Yeah. I mean, you can make it a capital if you want. So if it's direct, you multiply, and if it is inverse, then you're going to divide. So we're going to practice these, and you don't have to write these examples down. We're just going to practice making the equation. The number of boys vary directly as the number of girls. That would be your equation. A constant. It's just a constant. Okay? No. I know. Yes. Well, okay. Varies is where you put the equal sign. And then directly tells you whether it's being multiplied or whether it's being divided. So when it says varies, you make an equal sign. So who wants to write the equation for the second one? Yeah. We haven't gotten to like using the equation yet. We're just making the equation. So it says the price varied inversely as the number. Do you agree?
Yes.
Okay, who wants to try the next one? There's enough for everybody to do one. I think, well, almost. 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 Do you agree with that?
I do.
Okay, who wants to do the next one?
Wait, do I have to write oh wait.
Yeah, that's the variable that it's wanting you to use. Yes. Okay, who wants to do the last one? Go, Jonah. Come on.
No, you got one person. Why do you always talk about it? You.
Do you agree? All right, so we're going to use this information in word problems. So don't write the whole problem. We're just going to work them. Okay? The number of boys in every classroom of a school varies directly as the number of girls. So Anna, would you like to come write the equation for it? The very first sentence of the problem tells you what equation to make. You agree? Okay. So now that we have our equation, we're going to go on to the next sentence. In one room, there are 8 boys and 2 girls. So we're going to put in 8 equals, so what is our K? We're not done. That's just our K. So our equation is now, that's our equation to this problem. Because our K is 4. And so if we have 5 girls in another room, how many boys are there? How'd you get that? Okay. Y'all see how that works? I mean, they get bigger numbers. Basic concept. Okay, so let's try another one. The number of revolutions per minute, RPM, varies inversely as the number of teeth in the gear. Do y'all know what inversely means? Okay, so as the revolutions goes up, what happens to the number of teeth? And then as the revolutions go down, the number of teeth go up. What about directly, real quick? What does that mean? So, like for the last example, the more girls that we had in a classroom, it meant the more boys that we have. And if we didn't have a lot of girls, then we wouldn't have a lot of boys. So yeah, they either both go up or they both go down. And then inversely, they're backwards. Okay, moving back on. Who wants to go write the equation for this one? Do you agree? Okay, you want to try and solve it? You're welcome. What?
Yeah? Yeah.
133 and a third.
Oh, what?
133 and a third.
Last answer?
Oh, yeah, it reduces.
Okay. Is that right?
Mm-hmm. Y'all see how that works?
Yes.
Hi, it works.
You're like that.
I was just playing.
Right.
All right, let's look at another one. The number of clowns was directly proportional to the number of performers. If there were 40 clowns when there were 20,000 performers, how many clowns would there be if there were 12,000 performers? Sure.
Do we leave it as a weird decimal?
Oh, you're talking about your K. Either one. You can make it a decimal if you would rather. Yeah, or you can write it as a fraction. Either one will be okay. Just don't round your K. If you get something that would round, then don't round it. Like leave it as a fraction. Because if you rounded your K, your final answer would be off.
I want to do it. Wait. Wait, what did you
Maybe I did it wrong.
Okay, that's right so far. I'm watching. What do you mean? Yeah, that's right. 23 would go to 2. Yeah, you didn't get that for your K? Did you get .002? That's the same thing.
It would, like, if it was 0.023, would that's
Times 10 to the negative something.
I was like, Jonah, you probably made like a 95.
I was so confident. What would I say? That's not.
Where did you get 500 from?
Did you get .0202? .002? It's the same thing. 24.
Yeah, that.
Yeah. Do y'all see how that works? Okay. It's not. There's not a decimal. It's just 24. Okay, so see if you can do this practice problem all by yourself. You what? Which is what y'all all got. Okay? Let's try one more. No. You could. So the number of revolutions per minute, RPM, varies inversely as the number of teeth in the gear.
It's always
Yeah. Well, they do. They are. That is a true inverse variation. So they like to use that one. If 60 teeth result in 150 RPM, what would be the RPM if the gear had 100 teeth? Alright, can I go over this one just in case you don't know how to do it? Yes, it is 90. So RPM equals K times divided by T because it's inversely. So 150 equals K over 60. So your K is 9,000. And then RPM equals 9,000 over T. So our teeth are 100. So our RPM would be 90. Alright, so what is your homework? Problem set? Yes, problem set 60. It is due the day after we come, or the day we come back.